So we're evaluating piecewise functions, and they look kind of funny. There's this f of x, and it's next to this really big curly brace. And then there's 3 different equations here, and there could be 2, there could be 4, there could be 5. But each equation here uses a different part of the domain. So the first one uses only x is less than -2. The second one uses x's that are less than or equal to -2, are greater than or equal to -2, and less than or equal to 5. So numbers between -2 and 5, including the endpoints. And then the last one uses x values that are greater than 5. Now I need you to have 3 colors for this. I'm going to color code these so we can reference which equation we're going to use. So I'm going to use red, blue, and green. So when I do these problems, the first thing I like to do is go through my list of what it wants me to find and decide which equation it goes to. Each value is only going to get plugged into one of the 3 equations. It's never going to get plugged into all of them. So for number 1, f of -8, I'm going to look at my domain and decide if it belongs in the green equation. Is -8 greater than 5? No. Is -8 between -2 and 5? No. Is -8 less than -2? Yes. So this is a red equation, and we'll plug it into the red one when we're done. We're going to classify them all, and then we'll plug them in. The second one is f of -2. And notice we have -2 written here twice. So the question is, does it fall into -2 less than -2? Or does it fall into this between statement because of the equal to? Well, it's in that between because -2 equals -2. So this is going to be a blue equation. Now the next one, 0. Where do you think 0 belongs? Is 0 greater than 5? No, so it's not green. Is 0 between -2 and +5? Yes, 0 belongs in here. So again, this is a blue one. For whatever reason, this missing parentheses. So can you take a second and decide which colors 4, 5, and 6 go to? All right, so let's look at these last through. 3. 3 is not less than -2. 3 is between -2 and 5, so we're going to make that blue. And for 5 we have written both places here, but it's equal to in the middle blue equation. So we're going to make that blue. It wouldn't be green because 5 is not greater than 5. And then the last one is f of 10. 10 is greater than 5, so this one ends up being green. Now we plug them in. When I plug it into the red, every time I plug it into the red, the answer is 3. So f of -8 equals 3. For the blue equations, I'm plugging it into x plus 2. So I get -2 plus 2 equals 0. So f of -2 equals 0. Still x plus 2, so 0 plus 2 equals 2. So f of 0 equals 2. And 3 plus 2 equals 5. So f of 3 equals 5. And 5 plus 2 equals 7. I'm plugging them all into the same equation, x plus 2, because they're all equal. And that's f of 5 equals 7. And now the green equation is the last one, 1/2 x plus 3. So I get 1/2 of 10 plus 3 is equal to 5 plus 3 equals 8. So f of 10 equals 8. Okay, so we have g of x is equal to 1/3, negative 1/3 x plus 2 if x is less than or equal to negative 3. So that's our red. We have g of x equals 1 when x is between negative 2 and 6, including the 6, but not the 2. And then we have x squared plus 1 if x is greater than 6. So we're going to color code these. G of 0 is 0 less than or equal to 3? No. Is 0 between negative 2 and 6? Yes. So this is a blue equation. And then number 2, g of negative 2. Well, negative 2 is not less than or equal to negative 3. And negative 2 is not less than negative 2. And it's definitely not greater than 6. So we have no place for the negative 2. It doesn't fit anywhere in the domains, so this one is undefined. And if you have to answer undefined on the homework, just do lowercase and make sure it's spelled right, and then you don't have to worry about it marking it right. It marked it wrong for somebody, and they used an uppercase. So the quiz generator gets very specific sometimes, I guess. So then number negative 3, negative 3 falls in here, right? Negative 3 is less than or equal to negative 3, so that's a red. And then 6. 6 is not less than or equal to negative 3. 6 is equal to 6 because the equal to sign is here in the blue and not in the green. We're going to use the blue. And then 7. 7 is not less than negative 3. 7 is not between negative 2 and 6. 7 is greater than 6. So this one we're going to use green. And then lastly, negative 4. Negative 4 is less than negative 3. So this one is red. Oops, thought I had the highlighter. So now we are going to plug them in and find our answers. Okay, and this is what the majority of tonight's homework is going to be on, with a little bit of domain and range review. Yes, every once in a while there is an equation that overlaps, and if that happens, it's not a function, it's just a relation, and then in that case you would actually put both. If we had 2 or equal to signs on the 6, then you would have to plug it in and it would actually get both. We generally try not to do that because we're trying to deal with functions, and if we have functions, then it should only have one output for that specific input. Okay, so blue equation is 1. So g of 0 equals 1, and g of 6 equals 1. There's no variable to plug it into. It's a constant. So every time I plug in something between negative 2 and 6, I get 1 for my domain, or my range, y value. Let's do the green equation because it looks slightly easier. X squared plus 1. So we have 7 squared plus 1, which is 49 plus 1, which is 50. So g of 7 equals 50. And of course, you don't have to do them in any specific order. And then lastly, negative 1/3 x plus 2. Here we're going to plug in negative 3. Negative 1/3 times negative 3 is positive 1 plus 2 equals 3. So g of -3 equals 3. And then we're plugging it in here too, -1/3 times -4 plus 2, which is +4/3 plus 2. Make that a fraction. Multiply by 3 to get a common denominator. So we get 4/3 plus 6/3, which is 10/3. So g of -4 equals 10/3. Okay.